This is chapter 11, question 9. It's from it says module 9. It's really kind of module 8 stuff. But we have a bunch of different states of the world: good, boom, poor, bust. We have a probability of those occurring. We have returns for different stocks. And we want to know, if we invest 30% in stocks A and C and 40 in stock B, what's the return on the portfolio and what's the variance and standard deviation. I have taken the liberty of typing all of these things out in preparation for this question and adding in the weights. So if you're doing this at home, go ahead and do it on your own. I just wanted to save time. So the expected return on the stocks is the first question. And this is the sum product, which, if you've been following along in the classes, you are probably pretty sick of now. But the sum product is the sum of the products of the probability times each individual stock potential return. So 0.2 times 0.24 plus 0.35 times 0.09 plus 0.4 times 0.03 plus 0.5 times minus 0.05. When you add those up, you will get this number. Now, notice that I locked notice that I locked the probability in column D. And what that allows me to do is copy and paste that all the way across. So this is the expected return for each of the stocks. Given the probability of each state of these states occurring, stock A should make 8.9%, stock B should make 7.25%, and stock C should make 5.4%. The expected return for the portfolio is also going to be a sum product, but here we're going to use the weights and the expected returns. I'm going to make that a percent just so we can see it, and the answer is 7.19%, which is exactly what we have here. Okay, now let's do the variance and standard deviation. The first thing, there's a bunch of different ways to do this, and I'm going to show you the easier way. I think it's just better. All right, if we have a boom and a bust, what portfolio return would we expect in a boom? Well, to do that, we're going to do the sum product of these stocks times the weights. Notice I lock the weights because we're going to have the same weights in every different scenario. Okay, so this is the expected return in each of these scenarios. So now let's do the deviation from the mean. It's just going to be that minus that. Let me wrap these. All right, now I'm going to square that. And now I'm going to take the sum. This is the portfolio variance. Oh, I did something wrong. I don't take the sum here, I take the sum product. And I will explain that in a second. And this is going to be that to the power of 0.5. Okay, let me just show you that we have the correct answer. The variance is 0.0272 and the standard deviation is 16.49%. We have both of those. Let me just walk you through the logic of how we did the variance calculation. So for each of these stocks, we have an expected return. Each of these states of the world, we have an expected return. So given our weights, 30, 40, and 30, this portfolio in boom times is expected to return 35%, in good times 11%, in poor times minus 7%, and in really bad times minus 14%. We calculated a deviation from the mean, which is how you think about a standard deviation. It is the deviation from the mean. We square the deviation from the mean because that's how you calculate the variance. And then we sum the squared deviations weighted by probability. And finally, we take the square root to get the standard deviation. The intuition here is that the expected return on the portfolio is about 7.9%, but in any given sort of deviation, we could see 16% plus or minus, which is kind of where we're getting some of these minus percents in here. Like notice the poor portfolio is down 7%. So although the expected return is positive, there is within one standard deviation a chance for minus, let's see, let's just do the range. So a one standard deviation range would be minus 9.3% to 23.68%. And it means that that is where the bulk of the distribution lies. Something like 68% of returns, in theory, should lie between minus 9.3% and 23.68%.